Ndio hiyo. Now it's
Oh,
recording.
yeah. Awesome. Yeah. Yeah.
Okay.
Okay.
Hi,
Awesome.
Frederick.
Thanks.
Hello.
Frederick. Okay. Awesome.
Hello.
Yeah. I hope you can hear me and you can see my screen.
Yes, I can.
Okay. Awesome. Okay. So, are you familiar with ICP? Because I was thinking we start from the beginning and then we go to the developer tooling.
I'm familiar with ICP. Maybe the people who will watch the video.
Oh, okay. Okay, then. Then I think we can start from there. Just a minute. Okay. So today's agenda will be introduction to the Internet Computer 101. So the presentation is based on the decade course, which is available for people to be able to do and be able to interact with ICP. So the agendas will be overview of the Internet of Computer, developer tooling, key features and benefits, and some of the use cases and examples within the ICP ecosystem. So Internet Computer is powered by the Internet Computer Protocol, ICP, which is kind of similar to what we have EVM, that is the Ethereum virtual machine, from which its utility token, the ICP token, derives its name, just like in Ethereum in a way. So there are core parts for ICP, that is the core parts of the ICP, or the 4 layers of the protocol that helps ICP to run on nodes for each subnet. So the architecture of many concurrent operating subnets enables the ICP to be able to scale practically without limits. So the core protocols for these are the peer-to-peer consensus, messaging route, and execution. So this is a diagram of the 4-layer architecture of the core ICP protocol, where we have the P2P, that is peer-to-peer consensus mechanism where it lies, and then the messaging route and execution environment. So we're gonna look at the 4 layers. That is the peer-to-peer layer of the internet, which is the bottommost layer, and it's responsible for the secure and reliable communication between the nodes of a subnet. So a node is basically a computer that connects with another computer and also communicates with another computer and shares information with each other. So when you say the blockchain is a digital, it's peer-to-peer ledger or a decentralized or a distributed ledger, it basically means that all those transactions and information are stored into the nodes. So it's the same case for this. It's also the P2P layer is also able to broadcast network between the nodes of the subnet, and also being able to, which is building upon the internet protocol. So that is the P2P layer. The other one is the consensus layer. So every blockchain must have a consensus mechanism that will be able to allow the nodes to be able to agree on the messages which are shared between each other. So like for us who are here within this call, we have agreed that the mode of learning or the way we're gonna be learning is using the Zoom tool to be able to communicate with each other, share the information, and maybe something like that. So consensus mechanism is actually an agreed upon rules that are shared amongst either people or nodes to be able to use or to be able to communicate with each other. So for more research and more understanding about consensus mechanism, I would really recommend to learn the different types of consensus mechanism. That is maybe something like proof of stake, benzenite fault tolerant, and other types of consensus mechanism. So the consensus in ICP protocol drives the subnet of the ICP, which the major purpose of it is of the consensus protocol is to give out the same block as ordered messages on each node of subnet. So that is it. So it's basically to be able to communicate with other nodes. So ICP consensus protocol also provides some cryptographically guaranteed finality, which is in contrast to Bitcoin-like protocols, which only provides probabilistic finality, where a block is considered final once a sufficient number of blocks have been built on top of it in the blockchain. So if you have done transactions with other blockchains, you may have realized that for a transaction to be called final or to be verified, it needs maybe like a number of blocks to be successful, like maybe 15 or 12. But for ICP, the consensus protocol is the one that provides the finality and also cryptographic mechanism to be able to say that a transaction is final. So we then have a messaging route. We have a messaging route component, which is the one that receives a block of message that needs to be processed from the consensus mechanism, from the consensus. So these blocks are the same blocks on each node of the subnet. So basically, when the recipients when the message are complete or the message are put into queue of maybe a targeted canister. So a canister is an equivalent of a smart contract in Ethereum. They create trigger and then they are executed. The execution is allowed to a new canister message. So the recipients may include canister residing on a different subnet. So if a canister is in a different node or a subnet, it can also be included. And the message layer implements the routing of other canisters. So we're gonna be able to understand more in depth what canisters are. So another very crucial functionality of message is implemented by the messaging route layer, which is the state of certification. That is the subnet certifying parts of the replicated subnet is in a decentralized manner. Okay, so moving on to the other layer. The execution layer. So the execution layer has a set of has parts, has unique features which are set apart for the ICP from other, which sets the ICP from other blockchains, and that one is the deterministic time slicing. So the execution is can be able to execute very large messages requiring billions of words WASM instruction to be executed. So we're gonna be able to also see more about WASM, what it means. There is also concurrency. So execution of canisters through the WASM bytecode is done concurrently on multiple CPU cores, which is possible due to each canisters having its own isolated state. The other one is pseudorandom number generator. That is through the execution of canisters. Yeah. So canisters can now execute algorithms which are very that requires randomness. Yeah. Makena, could you kindly provide the password for joining? Somebody wants to join for the meeting. Okay, so we spoke about cryptography and that ICP has cryptography. So we also say that consensus mechanism for ICP also provides cryptography. So we can look more in depth what the cryptography looks like. So you may also want to check out the different cryptographic methods available on the internet, not on the internet, but in different blockchain which is used. Yeah. We have things like digital signatures, public key cryptography, and other cryptography mechanism. So yeah, so for ICP protocol, it uses a toolbox of advanced cryptographic mechanism known as the chain key cryptography, which allows the ICP to be able to achieve functionalities and scalability that are impossible on other blockchains. So one of the key benefits of the chain key cryptography is that anyone can be able to verify the content received from the internet computer by simply validating a signature without having to sync with the entire blockchain. The other one is the topology of ICP can evolve autonomously. So new nodes and subnets can be added. Faulty nodes can be recovered, and protocol can be able to be upgraded autonomously without the need or intervention of anyone. And then the other last one benefit is a source of unpredictable and unbiased pseudorandom numbers for canisters canisters can also be able to securely learn those algorithms that need randomness. So yeah, there is something called randomness. It's something that you may also may want to learn more about it. Yeah. So another good aspect about ICP is the integration of Bitcoin. So Bitcoin integration on the internet computer sets on two pillars through the chain key signature and a direct interaction between the internet computer nodes and the Bitcoin peer-to-peer network. So where the chain key signature makes it possible for canisters to have their own Bitcoin addresses and also be able to create valid transactions, spreading Bitcoins held by this address and also the direct message exchange between the ICP and the Bitcoin network serves as a way to be able to maintain information about the Bitcoin blockchain state. And yeah, so such as the state or maintain the information of Bitcoin is mainly through balances and other aspects that needs to be maintained. Yeah. So you can be able to easily integrate Bitcoin on ICP. This is more on chain key. This is more on chain key and how the connection or the integration of Bitcoin cars. Yeah, so we won't dwell that much on that. Yeah, so the other part of the half of this other session is the developer tooling on the ICP. So for you to be able to understand, or for you to be able, as a developer, for you to be able to build on ICP, you may need to know some of the tools that are available on ICP, or some of the similarity and contracts, contrast with Ethereum blockchain. So I know most of us, or most developers, have already been able to interact with Ethereum and have been able to deploy something on the EVM. However, there are some downside, which is you won't be able, as a developer, you do need to know the tools. And to make it easy for us to transition to building into ICP, you may need to know some of the tools which are popular in ICP. So I've been speaking a lot about canisters, which are equivalent to smart contracts, gas, which are equivalent to cycles in ICP, web3.js, which these one are libraries for JavaScript and TypeScript in Ethereum. But for ICP, we have agent under JS or Node ICO. We have an RPC, which is used to connect to an EVM or an Ethereum node. For ICP, ICP HTTPS interface. Then we have Solidity for creating smart contract. For canisters, we use Motoko or Adzo. And for today's session, we're gonna be setting up our environment for Adzo. Yeah, so once you deploy and compile your smart contract in Ethereum, you get ABIs. But for ICP, you get Candid. Yeah, and then there is a difference between the founders. So we have Vitalik and Dominic Williams. Okay, so like I mentioned in the beginning of this session, we have ICP Adzo Development 101 course, which is available on Decade, and anybody can be able to do it and be able to earn themselves 20 ICP, which are where one ICP is around $4 per now, which is good for developers, so that you can be able to learn and earn without having to, like, you feeling like you have maybe wasted your time. Okay, so smart contracts in the internet computer come in the form of canister. So they are computational units that bundle together code and state. So one thing is that each canisters can be able to define functions that are called by other canisters and parties externals to the ICP, such as browsers or mobile apps. So just like the same way we have smart contracts in Solidity, where you have functions being able to be called by other functions being able to be called by other canisters, all the same way you kind of define smart contract in Solidity is the same. Yeah. So canisters can also be able to communicate with one another via asynchronous messages, but they also execute the execution of each such message is done in complete isolation. Yeah. So, yeah. So we just a minute. Yeah. Uh, so canisters can be able to communicate with one another via asynchronous messages, but the execution of each such message is done in complete isolation, being able to allow massive levels of current execution. The canisters are managed by controllers, and controls structures of canisters could be centralized. Maybe like when you have the controllers include some centralized entity, and like normally we centralized entity, and where you have decentralized, like when the controller is a DAO or even an inexistent, in which case the canister is an immutable smart contract. Yes. Oh, okay. Yeah. So these controllers are the only entities which can be able to deploy the canisters into the internet computer. They can be able to start and stop their execution, and they can be able to update their codes. So the controllers also do need to ensure that canisters hold sufficient circles. So like I said, circles are gas. So the controllers need to be able to ensure that canisters can be able to hold sufficient, what you would call gas in Ethereum, that is circles. So yeah, so that is about canisters, and yeah. The next is how to get started on what is Adzo, before we get into getting started on building and setting up an environment. Yeah. So Adzo is a TypeScript canister development kit, that is CDK for the Internet Computer Protocol. It provides a set of libraries and tools that make it easier to be able to build and deploy canisters on the ICP platform. So Adzo also allows web developers to be able to bring their TypeScript and JavaScript skills to the ICP and use various NPM packages and VS Code intelligence. So if you have already been able to interact with JavaScript and maybe TypeScript, it's gonna be easier for you to be able to build on ICP. So one thing you do need to note is that Adzo is still in development and does not yet have many live or all successful continuously operating application deployed onto the ICP. Mainly for different developers prefer to use Motoko because it's continuously evolving. But for new developers or beginner developers, it's good for you to get started with Adzo because you may have been already interacted with TypeScript or JavaScript. Awesome. So I don't know if there is any question up to where we have or where we at, because it's now we need to start getting our hands into the code. So to get started, you will need to have TypeScript. No, you need to have knowledge on TypeScript, and you need to be familiar with Node.js. Yeah, you also need a VS Code to be able to write your code. You also need for Node, you need to make sure that the version is version 18 and higher. Okay, so I think we can get started. We can quickly visit arcade.com, .org. Yeah, so Fred, uh, maybe you can share what you already have so that we can be able to see how we can be able to get started. Okay. Hello, Fred, can you hear me? Fred?
Jordan.
Hello, McKenna. Can you see my browser? Am I
Yes, you
sharing
can
my?
see it.
Okay. The
You're sharing your screen, the screen of your.
the presentation of the entire browser.
No, we are seeing the home of your machine.
Oh, okay. So I'm gonna visit. I've already visited Decade for a couple of times. So we're gonna visit Decade.org, and then we may need to. If you don't have an account with Decade, you may want to sign up for Decade. It's taking a little while to load. Yeah. Okay, awesome. So you will need to load Decade.org, and then on Decade.org, you log in or sign up. So log in or sign up so that you can be able to also meet and yeah. So if you scroll down, you will see different communities to be able to participate or how you can be able to like learn. So the first one is internet computer. It's the first one. That is ICP. So you can just click on ICP, get started. And once you click on get started, you'll see different people who have submitted and the points they've been able to get. Yeah. So click on getting started. As you can see, this course is beginner friendly. So we have this. So you can start with the basics, learning and understanding and being able to get more resources on what blockchain is and being able to understand what ICP platform is and how it differs from other blockchain. Yeah. Hello, Sam. Okay, so we've already covered what is Canister, what is Adzo, and the prerequisites. For tech stack, we have also been able to do that. So you need to know Adzo, which is TypeScript. You need to have Node version 8. So to download Node version 18, just go to node.js. And then you go to the official node.js, node.js.org. So you may also need to, just a minute, let me exit this. You may want to create a folder path and call it ICP shade. And then on ICP, you need to open your terminal. So for the terminal, make sure you for guys who are using Windows, if you're using Windows, first of all, you need to, if you are using Windows, you need to download something known as WSL2 download. You need to download it. So you may want to download it. Let me just check. Yeah, so this is the documentation for installing Linux on Windows with WSL. So you need to open PowerShell, install the WSL. Let me share this one on chat. So Fred, which machine are you using, or which operating system are you using?
Linux.
Okay, awesome. So yours will be easy.
This I'm covered.
Yeah.
I'm covered on this. I use Linux.
Okay. Okay. You are really good. You're good to go. So you need to have installed WSL2 version 2. Yeah. So for Windows guys, follow this site to do that. Okay. So the other thing you do need to have is DFX. So you do need to have DFX. Or to install DFX, you can go to internet. Internet computer. .org. So you need to go to internetcomputer.org, then scroll to developer tools, developer tools. And then under developer tools, you need to click on the DFX. So that is DFX. Yes, Fred. Hello, Fred.
Hello, I'm on.
Are we following along?
Yeah, I'm following.
Okay.
I know how to install DFX.
Okay, awesome. So you need to install DFX. The installation.
Now, there's a second alternative of installing DFX, passing through the tutorials.
Yeah.
I think
There is also on the tutorial part there is a way to do that. This one, yeah. So this is the command for installing DFX. This is what I was looking for, DFX. But if you also want to learn more about DFX and its command line, you can just visit this site. Yeah. So let me do that. Open it on VS Code. So the new folder we created, we are opening it on VS Code. In Ubuntu. So I'm gonna be using the Ubuntu 2.22 for this. Okay, so So what I'll do, I'll just confirm, first of all, if I have to DFX. Version. Okay. A minute. DFX. So if you don't have DFX installed, if you don't have DFX, if you don't have DFX, you can just go to the installation, just copy the URL, and then you can paste. I don't know why it's not showing the version that I do have, but yeah. So that's how you just do the installation, just like that. So let's give it a minute to do though. Uh, yeah. So you do need to install. I think I may have had I have to Ubuntu. So I think that's the reason why I'm having trouble confirming. Let me check on this other one. So it may take some time to install. So one thing, as we wait for that to finish up, we can be moving on to this other part, getting started. So first of all, you do need to clone the repository, do UCD into ICP, add the boilerplate, and then you do npm install so that you can be able to install all the packages. And then you add, you can use either NVM or if you are using Node version 8, you don't have to use NVM, but NVM is a Node package, it's a Node version manager. Yeah. So to be able to understand the boilerplate, there is something known as tsconfig.json, which is going to be located on the directory of your project, and it's a setup file. So there are things that you do need to make sure that they are always there when you are creating a canister. So outside directory, arouse JS module resolution, that is the node. Strictly property for initialization should be always be false. Yeah. And then this will be able to help you to configure TypeScript so that you can be able to light your canister in TypeScript. These are configuration or compiler configuration options for TypeScript. So you can be able to read more about the TypeScript config file on TypeScript documentation. So the other thing you do need to understand is the DFX. The DFX, that is the library for drawing canisters. So we have the build type, the message board, that is the type custom, should be custom. The root folder for your canister. The file itself, like the source, that is the index for the index file, where the candid will be stored. So once you compile, the ABIs are supposed to be stored in source folder and in index.did. That means the candid. And then we have the WASM. Yeah. So WASM directs the DFX to our compiled WebAssembly files. So they are fast, efficient, and they are source secure binary instruction formats that gonna help in communication. Then we have the normal package.json file, which has the name of the project, the index.js, and all those, and also the versions of engines. So the various versions of Node .js, and yeah, so this is where now you also have your other dependencies. Yeah. So once you have understood the folder structure, you will be good to go. So yeah, let's see if it has completed. Okay. Yeah, so this is the other one. So DFX, that one. Let's see, alpha one. Okay. So it may give you some problems even after installation. So you may want to, so it can be recognized globally. So you may need to export your path. Okay. We can just use the other one. Won't bring us harm. So yeah. So let's go back. This we copy Git. Make sure you also have Git installed in your machine. on. Okay, so then we do need to CD into ICP, the point of it. And then we do npm install. So this is a folder. Then so this is the index.ts where the code for canisters will be all your code, all your logic, all your controllers will be within this part. The other one is the DFX that I was talking about, how it's gonna. So once you deploy or you compile your canisters, the candid folder, you can maybe if you want to have a more clean folder structure, you can actually restructure this one to where you have something like this candid. Yeah, and then the source folder will have now candid and index. So all your candid or all your ABIs, what we call in Ethereum, will be stored there. And then the entry point for canisters will be index.js. The main one, or the main of the entry file to your TS will be that one. So, okay, so as we wait for that, let's go back to the canisters, the definition of canisters. So we have dependencies. So we're gonna be using Adzo, and once you install Adzo, you do need to import all these dependencies. We already know what UUID version 4 is. What we don't know or what we are not familiar with is all these functions or methods within the Adzo library. So query, basically what it does enables us to be able to retrieve information from our canisters. Update helps us in facilitating in the updates. So remember, I kind of mentioned the CRUD operation, that is create, read, record, and delete. So record is for creating a new record or data structure in Adzo or in canisters. Then we have stable B tree map, which is used for creating a map data structure. We have VEC, which is used for creating a vector data structure. And then we have all these other ones, the results, which are used for creating results. NAT64 is used for creating 64 unsigned integers. So this, you can think of some of these as ICP or Adzo data types. Yeah. Then we have creating OPT or optional data. So you may need, so like normal importation in the key word being import here, it's the same thing which is used in for Redity and also in JavaScript and TypeScript. Yeah. So we talked about message when we were defining the messaging router and the execution. So you do need to define your message before you can be able to start to write the logic of the canister. It's very important that you define the structure of data and how it will be working. So this is that is the message. So that is the message. So this definition helps to ensure the consistency and clarity when you are dealing with messages in the smart contract. Yeah. So yeah, so this is a type of message. It has an ID, it has a title, it has a body, it has attachment URL, and also has a created art, and then we have updated art, which is kind of a representation of date and time in ICP. So like I said, you can think of these, some of these as data types in Okay. So, and you, after you have defined the message, you also need to define the payload type or the information that is going to be recorded on the message. Yeah. So I think we have installed everything. Yeah. So we can go to index. So the first thing that we do need So I think we can I think we are good with the installation and also with the WSL. So for those who are using Windows, they may need to, let me go back to the site. You may need to visit WSL if you are on Windows. Install WSL so that you can be able to install Linux on your machine. So use this documentation from Microsoft on how to be able to install WSL. The other thing you do need is Node.js for your application. You can also add Node version manager if you want to have different Node versions. That maybe you may be working on another project which requires Node 16, and you don't want to remove Node 16. You may also want to add NVM. So let me share this on chat. The other thing you do need to have is you need to have DFX installed in your machine. DFX installed in your machine. So you can visit the internetcomputer.org. That is the other link. And for you to be able to follow along with this tutorial, if you'll be joining us on YouTube or the next workshop, you need to register for the kid. Yeah. So for the next session, we're gonna start from this session. Hopefully everybody will have been able to have installed the required tools to be able to continue with the course. So thank you guys for joining us today. I'm gonna give this back to McKenna if you may have something to add or whether you have something to communicate. Thank you guys for joining.
Thank you so much, Jordan, for the presentation and for guiding us. I'm looking forward to next week, same time. Please share with your friends, share with your fellow developers. Every Wednesday, we have this online workshop from 7 to 8 p.m. East African time. That's all from my end. Have a lovely evening.
Okay. Bye everyone.